Today we're going to look at vibrating strings. Vibrating strings on musical instruments are all controlled by the same factors, and the factors are sort of described down here. So frequency will increase as the length of your string decreases. Frequency is also will increase when we increase the tension on our string or tighten the string. Frequency will increase when the diameter decreases. If you have any experience with guitars, the thinner strings have higher pitches. So there's a low E at the top of your guitar and a higher E at the bottom. The difference between those two strings is primarily the diameter. And frequency also increases when the density decreases. The actual relationships are expressed mathematically over here. Now, please notice that they are all relationships that are F1 to F2. So our original frequency or fundamental frequency is at the top, and then the changed frequency is down at the bottom. The other thing that I want to sort of draw your attention to is the equation with tension. Unlike the other equations, the change in string is going to be 1 over 2. The others are all over 2 over 1. And also it includes a root, which is going to make the math just slightly more challenging. Now, a really nice thing about all of these equations is that you can change more than one thing at a time on a guitar string, so you can change the length and tension. That just is simply going to be a product in the frequency change. So the factors that affect frequency can be multiplied together. Okay, now the actual solving of these problems is pretty straightforward. So the one thing you're going to really pay attention to is the fact that our units must match. Okay, so it doesn't matter if we have our lengths in centimeters or meters or any different unit, but they have to match. So if I have one length in centimeters and another length in meters, I'm going to have to make sure that they're both in the same unit. Other than that, it's just simply finding the variables in the question and assigning them the appropriate designation. So in this question here, we have a length of 30 centimeters, produces a frequency of 288. What length do we need in order to produce a frequency of 384? So then we just look up at our equations. We're going to use the one with length, and it'll look something like this. So the equation takes this form here, F1 over F2 equals L2 over L1. And the one thing we're going to have to be careful with is our algebra. So we'll substitute our values in. It'll look like this, which we then can evaluate to give us an L2 value of about 22.5. Now I'm going to skip over the next couple problems and focus in on problem 4. Now I picked problem 4 because it has more than one thing changing in it. So if you read the question, you will identify the following variables. So if you read the question carefully, you should pull these pieces of information out of it, and then the rest will just be some algebra. So the equation we'll use to solve this problem will be F1 over F2 is equal to, now we've got two variables changing, so it'll be the product of the length difference times the difference in tension. And on the next slide, I will go through the algebra for that. So here's the completed solution for the frequency change that's caused by an increase in tension and an decrease in length of the string. So you just take the product of your differences in lengths and your differences in tensions, and then solve it with the frequencies. All right, there you go.